All right, eighth graders. So in our last video, we left off talking about um, applications, how to create those linear functions. We're just going to continue on with our next example here. I just didn't want the video to get too long. So here we go. We're going on a 5-day vacation. Don't we all need one of those again? And we bring $105 for spending money. So that's our start, right? That's what we're starting with. So that would be our y-intercept because that's our starting amount. We spend, you spend, so that means we're doing a negative $17. Oh, there's that keyword each. So that's telling us slope for the first 4 days. So we want to write a linear function that describes the amount of money A, so that's going to be like our y, that you have after D days, which is going to be our x. So we're going to have A equals our slope, which is negative 17, right? Because y equals mx plus b. So negative 17x plus the 105 we started with. Now, the other way to write this is that, oh, I put x again, and I should have known we're changing letters. Instead of x, that's d. The other way we can write this is the fact that amount of money starting at 105, subtracting 17 per day. So both of those are correct answers for our linear function. From here it says, on the last day you want to buy a sweatshirt that costs $36. Do you have enough money to buy the sweatshirt? So we're needing to figure out after 4 days, how much did we spend? So how much do we have left? If it is greater than 36, then we have enough. If it's less than 36, then we don't have enough. So we're looking for A. I'm going to plug into this 105 minus. So 105 minus 17. Our days, we've gone 4 days. So we're going to do 17 times 4. So then A is going to equal 105 minus 68, because 17 times 4 is 68. And then 105 minus 68 is 37. So barely, but do we have enough money to buy the t-shirt? Yes, let's just hope they don't charge a lot of tax, right? So yes, we have enough to buy the t-shirt. All right, next example. So we're going to write a linear function for the graph where y is the total change and x is the number of years since 2000. We're going to talk about that in a little bit. So let's first start with our y equals. We need to find our slope. Our y-intercept is going to be easy on this one. Our graph starts at 0, 0, so I don't need to put a plus b here. I just need to figure out what my slope is. And so I know that when I look at the graph, it looks like 1 over 1. But really, my x is the only one going by 1s. My y is going up by 481 each time. So for this box, I went up 481 over 1. So m, my rise was 481. Sorry, the cat decided to join me again. Over 1, which that makes my slope 481. So y equals 481x. That's our linear function. From here, we want to know what would the total change, because this is change over time, be by 2017. And so X is the years since 2000. So what you're going to do first is you're going to take 2017. I hope you could actually do this one in your head, but just for posterity of in case you have years that you can't just subtract in your head and know the difference, you're going to take 2017 and you're going to subtract 2000. And so that is 17 years. So we're going to work with x is 17, and we're going to do y equals 481 times 17, because that's what's going to tell us our change over time. And so 481 times 17 is 8,177. And so that is our change over time. All right, that is our last example. This last one had us using a graph to figure out our equation. We can always, look, like I said before, don't just say lots of words, I'm going to skip it, and I'm just going to go straight to the graph or whatever. Read through, because a lot of times that's the easier way to find your linear function is in the paragraph and not so much always the graph. So until next time, 8th graders, peace out.